Hello everybody, welcome to Seattle. My name is Mike Gelb, and I just want to say that I'm a much better skier than my colleague Jesse Zalatan is a snowboarder, as you can see if you watch his video. So the main area in the Gelb Lab is research in newborn screening of treatable genetic diseases. And what I'm going to do is show you a short video that describes the essence of the work that we do. So have a listen.
Children with late infantile onset metachromatic leukodystrophy lose the ability to walk, talk, swallow, eat, and see. Most kids with MLD won't survive beyond their 5th birthdays. In 2010, using stem cells derived from their patient's blood, researchers pioneered a treatment to repair the defective gene that causes MLD. Giovanni Price was the second child in the world to undergo this treatment. Today, Giovanni is 5 years old and has no symptoms of MLD. On August 24, 2015, Giovanni Price did something no child with this disease has ever done before. He walked to school for his first day of kindergarten.
When he was born, his genetics were that he, by the age that he is right now, should be close to the end of his life. And so we see the complete opposite. I mean, we see him going to school and making friends and riding his bike in the driveway. And the doctors don't tell me he's, they've never used the word cure. They've never told me what's gonna happen because they don't know. I mean, we don't know, but I hang on to those words that he's gonna continue to grow up just like any other 5-year-old. My hope is that gene therapy combined with newborn screening for MLD will save other families from going through what we went through and what all of our friends, our MLD friends, go through with their kids. He has no idea that he's a miracle. He has no idea.
So the main goal in the Gelb Lab is to develop new technology for newborn screening. And I think it's fair to say that we're the top laboratory in the world, as we have produced virtually all of the recently developed newborn screening tests that are used around the world. Newborn screening starts with dried blood spots. When babies are born, a small amount of blood is deposited onto a filter paper, and this is sent to the newborn screening lab. One type of newborn screening is to measure the activity of specific enzymes in these dried blood spots. And to do this, we have to design and use organic synthesis to prepare highly specific substrates for the enzyme of interest. Here's an example of an enzyme that hydrolyzes linkages to carbohydrates. The substrate is converted to product, and this product is then detected by tandem mass spectrometry. And we can use an internal standard that is, you see, chemically identical to the enzymatic product, but substituted with deuterium so that the product in the internal standard gives separate mass spectrometry signals. So again, we use a lot of organic synthesis to prepare these enzyme substrates. Here's a typical chromatogram where analytes in these dried blood spots are sent through a chromatography column and then into a tandem mass spectrometer. And we can detect numerous enzymatic products or biomarkers that are signatures of the various genetic diseases that we're interested in. And so this shows you, I think, the power of mass spec, where we can multiplex these assays and detect analytes relevant to many different genetic diseases in the same analysis. Not only do we go to scientific meetings in the newborn screening area, but a particularly rewarding event is to go to meetings organized by families with affected children. And we get to describe to them the newborn screening technology that we're developing. And I think they really appreciate what we're doing to try to help these kids. So here's a couple of photos of my current research group, and I hope you get a chance to talk to some of the group members about their work in newborn screening.